In this last video on factoring polynomials, I just want to summarize and recap what we've seen in the previous videos. So your steps for factoring are as follow. Your first step should always be to see if there is a GCF that you can factor out. If the GCF is 1, then you're not going to worry about it. But if you have anything else, then you want to factor that out. And don't forget at the end of the problem to make sure that that's part of your solution in your factorization as well. Next, you're going to look at your polynomial. So if your polynomial has 2 terms, then you can try one of the special techniques that we've already seen. So you can see if it's the difference of 2 squares, you can see if it's the difference of 2 cubes or the sum of 2 cubes. And if those fit, then you have the formulas that you can use there. If there are 3 terms, then what you can do is either try factoring trinomials by trial and error or factoring trinomials by grouping. For me, it really doesn't matter what technique you use as long as you know how to factor. So unless a problem specifies what technique you should be using, then it's totally up to you. And you can use either one that you like, or you can even switch back and forth between the 2. If you have 4 terms in your polynomial, then you're definitely going to factor by grouping. That's the only technique we have right now for how to deal with 4 terms. So that's the one you want to use there. Once you've factored, you do want to check your result to see if any of those factors can be factored further. So every once in a while, you may think you're done, but if you still see some square terms in there, or if it's a GCF left over, you need to make sure you factor that out. So you always want to double check. And of course, you can remultiply everything out to check your final result as well. So you can always do the multiplication check too. Now, one thing I want to mention, which I kind of did not really talk about in the other videos, is that some polynomials cannot be factored at all. So there's no GCF besides 1. You try every technique you can think of, and you just can't do it. Nothing is working. So in a case like that, the polynomial is called prime. It has no factors other than 1, basically just like a prime number does. So some examples of polynomials that are prime is this one here. So notice that the sum of 2 squares is always prime. It doesn't matter what 2 squares they are, you're never going to be able to factor it. So x squared plus 4 is a square, right? It's 2 squared. It's not going to be factored. Those are the only examples, though. Sometimes you could come across a polynomial in 4 terms or 3 terms that just can't be factored either. And this is one of those examples here. So I encourage you at home to just try. If you have this trinomial and you're thinking about trial and error, well, this would be x and x. And the only option here is 1 and 2 or -1 and -2. No matter what combination I try for trial and error, I'm never going to get a 5 in the middle. It's just not going to happen. If you're using the grouping technique there, your AC term is 1 times 2, which is also 2. So you have the same factors here. And again, there's nothing there that's ever going to get you that 5. It just doesn't work. So something like that is prime. It cannot be factored. And of course, both of these don't have a GCF besides 1. So there's absolutely nothing you can do. Sometimes we can at least take a GCF out, and then we may not be able to go further. So there's at least something you can do. But if there's nothing at all, then that is called prime. So let's do a couple of examples in this video and just kind of put all of these tools together. And if you want to, you could always leave that sheet out next to you, maybe kind of have it with you or put it on an index card just to have those general steps. Okay. So here I have a trinomial. I see 3 terms. But before I start, I'm going to look at the GCF. And again, this is kind of like our finished video of factoring. So you're going to see some harder examples here. This one has a GCF that's not 1. So our GCF here, if I look, all of these have a factor of 2 and of x. So my first step is going to be to take that GCF right out. So here I'm left with x squared, and then I'd be left with 4x, and then I'm left with just 4. So I'm going to factor that GCF right out. And now I'm going to keep going and factor this further. I'm going to see if I can keep factoring it. It's a trinomial, so you can use trial and error here. You can use grouping method. Whatever works for you is fine with me. This one's pretty simple, so I think I'm going to do just trial and error. I say it's simple because my leading term is only an x squared, so I know my factors are pretty basic there. And then I want to get that 4 in the middle. So again, I'm doing trial and error. You can try this at home. And the one that's going to work there is that x plus 2, x plus 2. If I go and multiply it out, I get x squared plus 2x plus 2x plus 4. So you get that 4x in the middle, and that would be the factorization. Now, make sure you put it all together. So our final results, you have the 2x here, that is still part of your answer. And then you also have your x plus 2, x plus 2. You could also write it with x plus 2 as a square factor instead. They're both correct. So just make sure you read the question carefully to see if they prefer one form or the other. But that would be your final factorization. And of course, you can double check. I don't see any more squares. If I look within my factors, I don't see a GCF there or anything like that. So we're good. All right. I want to just do a little side note here. So let's say you finish the problem. And your answer is x plus 4, 2x minus 10. And let's assume that is correct. So I'm just making up a problem here. You want to do that double check. So you may notice that there's no squares here, but if you look carefully within this factor, there's still a GCF, right? So if you still see something left over, this is what I'm talking about double checking as well. You do need to take that out. So if I fix this one here and I take that 2 out, I'm going to then rewrite my final answer as 2x plus 4, x minus 5. Okay, so check the factors. This was that step here. Check the factors at the end to make sure you haven't missed anything. So if you miss a GCF, or if you notice that there's still a square left and you can break that part down further, you definitely want to do that. So you want to factor these totally completely. All right, and let's just do one more example. I'm actually going to go to a new page, make it a little bit easier to follow along. Now, this one here is really a challenge problem. It has hidden squares in it. So this one's really tough. Okay, so this is like as tough as it's gonna get here. So this one's a little bit weird. If I'm looking at it, I kind of see this a term. I'm like, why is that a term in the middle there? So what you can do when you have a polynomial, particularly with 4 terms, is sometimes you may want to rearrange it to make the terms match up a little bit better. So one thing that we can do here is just kind of rewrite this. I haven't changed the problem, but I'm kind of putting the x stuff together, and then I'm putting the a stuff at the end. Okay. And now I'm going to look for an overall GCF, and I don't see one. So that would be your first step here. So try to factor out that overall GCF. And I'm saying that this one is sort of a challenge problem because we haven't seen anything like it, and it is really tough. What I'm noticing here is that this is a perfect square, right? 25a squared. So that's kind of jumping out at me. And if we actually play around here and factor this piece up front, we actually would see that it is also a perfect square. So if you factor this, and you can do it by trial and error, or you can do it the grouping method because it's a trinomial, you're going to see here that you actually have a perfect square. So you have a perfect square here, and you happen to also have a perfect square here. So this problem ends up being the difference of two squares, right? I have a square here and a square here. So I have x plus 4 squared minus 5a squared. So remember, for that formula, when you have a squared minus b squared, you're going to do a plus b and a minus b. So our a here happens to be x plus 4, and our b here happens to be 5a. So when I factor this, it's going to be x plus 4 plus 5a, and then x plus 4 minus 5a as my factorization. Now, if I look within my two factors, I can't simplify anything. There's no like terms to combine there. There's nothing to really do, no more squares. So this ends up being our final result. But again, this is really a challenge problem, right? So this is not something that most people would recognize. Even myself, if I saw this, I'd say, wait, what? This is not one of those standard ones that we've seen before, right? If I see 4 terms, I'm expecting grouping method, and that's not what's going on here. What happened is that there's a hidden square there. So it's kind of sneaky. So you just want to be careful as you're going through the more complicated problems. Not that you may see anything this complex, but that there could be squares there or cubes there that are hiding. Or sometimes with 4 terms in particular, you may need to rearrange to get the grouping method to work. And that does happen sometimes too, where you have a little bit of rearranging that you have to do to actually get it to work correctly. So don't get discouraged. Keep trying. If you have found that when you factor that there's nothing that you can do, then it's probably prime. Not every question is going to be prime though. So if you're going through the homework and every single question is showing as prime, or you think is prime, then go back and check. You're probably missing something, but do be on the lookout for a couple of them along the way.